Hans in the Netherlands, which I assume to be Holland, writes, and he says, "Hey, Paul, can you explain why we, on one hand, talk about 24-bit and the need for an amplifier with a huge dynamic range to benefit from that, while recordings are often only 6 to 8 dB of dynamic range? Even a golden one, like Dark Side of the Moon, is only like 15 dB of dynamics." I don't know if that's true or not, but let's assume that what Hans is saying is true, just for the sake of discussion. So even a 16-bit is already overkill. Where does my thinking go wrong, and why is it important to have such high dynamic range? Well, that's a reasonably good question. And I don't have a reasonably good answer, but let's just talk about it. So just to give you some background for those, because I never know who's joining us on this channel, whether it's a first-time person or not, but a digital audio signal basically has two components to it. It has, and we're talking about PCM here, not our favorite, which is DSD, because that works in an entirely different way. But if we're talking about standard pulse code modulation, PCM, the two factors in it are sample rate and bit depth, okay? So the bit depth is how big of a number we can write when we mathematically look at a signal, right? And the more bits, 16-bit, 24-bit, 32-bit, 48-bit, that basically says how fine are the gradations of how we divide up the amplitude and how tall we can make it, right? And tallness, the difference between the loudest and the softest, is what we refer to as dynamic range. The other side is sample rate. How often do we take a snapshot of the incoming audio? And on a CD, we do that once every 20, it comes in at 44.1 kilohertz, okay? Which means we're taking a couple of, it's like 2 samples for 20 kilohertz. And that's how often we do a snapshot. And then when we take that snapshot, when we divide it up into little incremental bits, how many of those bits, how big can that number be? And basically it's how high can you count using 16 or 8 or 32, and you can look that up. I think we can get 96 dB with 16 bits, if I remember correctly. So that's the theoretical max. And as we go, we can get up to 140 dB with many more bits available to us within the stream. So why do we need that? Well, of course, as engineers, we like to design things for the eventuality of having something that actually matters. Take, for example, octave records, which that we have and I'm very passionate about. At Octave Records, we do exactly the opposite. We live for dynamic range. In fact, Jessica Carson, the executive director, and I are working on a very special release that is all about dynamics, okay? We're going to show you dynamics that's going to set your hair on fire, because well, that's what we do, and it's fun. It's really cool. And, you know, you're going to crank that sucker up and listen, like, keep everything quiet, listen way into the music, and then it's going to come roaring up like you know, a crack of lightning, and what fun. So, you know, dynamics is, to me, the heart and soul of music. Much today has a lack of dynamics, as Hans brings out. And it's true. It seems to be getting worse. It's one of the reasons we started Octave Records, to try and, you know, at least bring some sanity into the world and some great recordings, okay? Because the compression is getting more and more and more. So do we need that many bits for that kind of compressed music? Well, no, not really. But I would argue we don't need that kind of compressed music anymore. Let's put it on the ballot. Let's get them politicians rolling. there ought to be a law against compression. Anyway, I don't know how we got off on all that, but that's we be just talking, and that's about all I got to say about it. All right, thanks for joining in, and the comment section is there for you to jump in and say what you like, and I appreciate it when you do. All right, talk to you tomorrow. Thanks.